A company installs solar panels in its premises to reduce its electricity cost. The monthly savings on electricity is in dollar, and the equation is modeled by, oh, please pay attention. A company installs solar panels in its premises to reduce its electricity cost. The monthly savings on electricity in dollar is modeled by S equals to 200 plus 5x minus 2x squared, where x is the numbers of months after installation. At what time will the savings on electricity stop increasing? Find the minimum savings. Okay, you can solve this question using two methods. Okay, please pay attention. That is question 3. We have let's write out the model. The model is S equals to 200 plus 50x minus 2x squared. This is the model, right? Okay, let's start with the first question. The first question is that we are to find the time that the saving on electricity will stop increasing. Okay, to get the time which the savings of electricity will stop increasing, we need to find the vertex of the parabola. Okay, please pay attention. It's simple. Just pay attention. Okay, you can solve this using two methods. Okay, you can solve it using differential calculus, and you can also solve it using this method. I'm going to show you both methods. Okay, just pay attention. Now, to find the savings, to find when the savings will stop increasing, we need to find the vertex of the parabola. To get the vertex of the parabola, we are going to use this formula: x equals to minus b over 2a. Okay, now look at the quadratic equation that we are given. Okay, a typical quadratic equation is represented as this: as squared plus bx plus c. Okay, so in this case, a is the coefficient of x squared, and the coefficient of x squared in this equation is what? Minus 2. So a is what? Minus 2, right? And if you look at the equation here, b is what? B is the coefficient of x, and the coefficient of x in this equation is what? Plus 50. So b equals to 50, right? And c is the constant term, that term that doesn't have any variable attached to it. Okay, so to get the vertex of the parabola, x equals to minus, now look at this, b is what? 50, right? So I'm going to have minus 50 all over 2 multiplied by a. A is what? Minus 2. Okay, let us proceed. Minus 50 all over 2 times minus 2. I'm going to have x equals to minus 50 all over minus 4, right? Okay, negative 50 divided by negative 4, that is what? 12.5. So x equals to 12.4. Do you understand? Now, don't forget that x represents the numbers of months, right? So the savings will stop increasing after 12 months. 12.5 months. Sorry, this should be 5. The saving will stop increasing after 12.5 months. Okay, the savings will stop increasing after 12.5 months. Don't forget, in the question we are given that x represents the months. Do you get it? And another way to solve this question, for question 1 now, another way to solve it is using differential calculus. Okay, in differential calculus there is something called stationary point. Are you getting it? The stationary point is a point whereby the curve the first derivative of a function is equals to 0. That is, the function is not changing. Are you getting what I'm trying to say? So we are given that s equals to 200 plus 50x minus 2x squared. At stationary point, the first derivative of a function is equals to 0. So to find the stationary point of this function, I'm going to have the s all over the x. The s all over the x will be equals to, if you differentiate a constant, you're going to have 0. Okay, if you differentiate 50x, you're going to have 50. And if you differentiate negative 2x squared, you're going to have negative 4x. Do you get it? Okay, now having found the stationary point, set the derivative equals to 0. Don't forget, I told you, at stationary point, the s all over the x must be equals to 0. So the s over the x is this, so I'm going to have 50 minus 4x equals to 0. To get the value of x, what do? Minus 4x equals to what? Minus 4x equals to minus 50, right? Because if this 50 cross the equals to sign, the positive sign is going to change to negative sign. So to get the value of x, you have to divide both sides by what? Negative 4. So I'm going to have this over negative 4 and this over negative 4. Hence, the value of x is what? 12.5. And since s represents the months, so that means that the savings on electricity will stop increasing at 12.5 months, okay? So you can use differential calculus and you can also make use of this method, okay? The vertex of the parabola is the maximum. Like, you know, if you plot a quadratic graph, this it might it's like a concave. Are you getting it? So the vertex of the parabola is this, and at the vertex of the parabola there is no changes in the position of the curve, okay? So that is the solution to that question. That's the first question. Now to get the second question states we should we should find the maximum savings, okay? To get the maximum savings, all you have to do now is that just plot the value of x into this equation, okay? That's what you're asked to do. Plot the value of x in the, into the original equation. The original equation is this: s equals to 200 plus 50x minus 2x squared, right? Okay. Now, when x is 12.5, I'm going to have s equals to 200 plus 50 multiplied by 12.5 minus 2 multiplied by 12.5 squared. Do you get it? Okay. S equals to 200 plus, now 50 times 12.5, that is 625. 625 minus, okay, minus 2 multiplied by 12.5 squared is what? 3. Okay, 12.5 squared is 156.25. 156.25. Okay, so s equals to 200 plus 625 minus 2 times 156.25. That is 312.5. 312 minus 312.5, right? Okay, s is equals to 512, because if you add this to this, you're going to have 825, right? 825 minus 312.5, that is 512.5. Okay, 512.5. Okay, so the savings will stop increasing when s equals to $512. You know that s is in dollar, right? So $512.5. Okay, so the savings will stop increasing when s equals to $512.5. Do you understand? Okay, you see, the concept of calculus is an important concept, especially those aspects that deals with optimization. So if you are preparing for WAEC exam, you might want to focus on this aspect. Okay, finding the derivative of a function to determine its critical point. Okay, using the second derivative to confirm whether a critical point is maximum or minimum. And you might also want to focus on the how to apply calculus to find the maximum or minimum value of a function, just like we did in the other time. We make use of stationary points, and you know, having gotten the stationary point of the function, we find the value of x by setting the derivative equals to 0. Okay, so okay, let's proceed to the next question. The diagram shows a.
To watch the complete class, kindly click on the link in the description of this video or the comment section. Okay, see you in the next class.